these are two graphs that we are going to transform according to the transformations that are obviously written here. But when you apply transformations, you have to do them in order of operation. And that's the main reason I wanted us to talk about this, is you can't just apply any old transformation any old way and think that the answer is going to come out perfect every time. No. So you have to go in order of ops. So what do I mean by that? For graph A, there are two transformations. There is an A value multiplying by 2, and then there's also a D value. How do I know that this is D? Because it's not inside the parentheses. So it's not a C value that's affecting the inputs. Nope, it's a D value that's on the outside, so it's affecting the outputs. So your A value is affecting the outputs by a multiplicative factor of 2. And then your D value is affecting your outputs by a subtraction of 1. Okay, this is all outputs that are being affected, but the order in which you apply it matters. You have to do multiplication before you subtract. Why? Order of operations tells us to. That's why we had to create a structure as far as how to simplify expressions. And the structure is parenthesis, exponent, multiply, divide, those are the same, and add or subtract, those are the same. So multiplication first. So multiply the outputs by 2, and then also subtract the outputs by 1. And so in that order, that's what you just literally have to do to each and every ordered pair. So this ordered pair, for instance, is at an output of 4. That's the 4th tick mark. So originally it's at 4, but not anymore, because what are we going to do to that 4? We're going to multiply by 2, and then we're going to subtract 1. So 4 times 2 would be 8, but then 8 minus 1 would be 7. So the new location of this ordered pair is at an output value of 7. Don't change the input at all. There are no transformations for the input on this one, none. So it's only the output that changes. What about this one? This one is at 3. Presently, it's at 3. So multiply by 2 and then subtract 1. So 3 times 2 is 6, minus 1 would be 5. So the new location for that ordered pair would be at 5. What about this one? This one is at an output value of 0, right? So be careful. It's over to the right 1 unit, but then it's not lifted up or down at all. It's just at 0. So the original location is 0. But not anymore, because we are going to multiply by 2 and then subtract 1. Well, 0 times 2 is still just 0. But then minus 1, it ends up down here just 1 unit below where it used to be. And last but not least, this one, the present output value for that is at -1. The output is at -1. And so we are going to multiply it by 2 and then subtract 1. So let's see, -1 is the original, but -1 times 2 is -2. Minus 1 is -3. So the new location for that ordered pair is down here at -3. Once again, notice my inputs did not change at all, only the outputs. And so if you connect those 4 dots, and oh my gosh, bear with me, this is comical. I cannot do this on a tablet. What is happening right now? Sorry. Oh my gosh, I've never had to draw one of these on my tablet. What is happening? Okay, so you do your best to, oh my goodness, connect those and make a new graph. So yeah, don't be laughing at my graph. I can hear all of you snickering. Stop, it's rude. So that's the new graph. And if you look at that new graph, by the way, compared to the original, can't you kind of tell that it has the same structure? It's just been like stretched out a bit. Like imagine if it was tied or attached to a rubber band of sorts. It's just elongated. It's not shifted. It hasn't like literally been picked up and relocated as much as it has been stretched. Because that's the main thing that's happening to that one. Yes, it's been lowered 1 unit as well, but it's really been stretched according to that factor of 2. So there's that one. So once again, order of operations, very important. And then this next one, let me switch colors just for the sake of switching colors. I don't know, sounded fun. Let's do it. This next one has 3 transformations. And once again, the order in which we apply those transformations, order of operations, that's it. Don't overthink it. Whatever the order of operations are, that is what you would do. So order of operations would tell us parentheses first. So within the parentheses, what I see is a -1. But what does that really mean? That's a horizontal shift to the right 1. Yeah, remember, opposite direction. So even though I see a -1, what that really means is horizontal shift to the right. Whoa, I just accidentally touched my little face on Zoom here. I need to move myself over here. Okay, sorry. Horizontal shift to the right 1. Okay, so that's the first thing. So what comes after parentheses, exponents? No. Multiply and divide. Okay, see this little negative right there? What does that really mean? When in mathematics, when we just like slap a negative on something, what do we really mean? We mean that it's getting multiplied by -1. That's really what that is a coefficient of -1. So imagine that that is a coefficient of -1. And so what that means technically, so you're literally multiplying by -1. The outputs, of course, it's on the out side. Multiply outputs by -1. But what does even that mean, right? So think about when your A value is negative, what does that really do? It just reflects the graph. So when we say multiply outputs by -1, what we're essentially saying is, oh, I'm just flipping it over the x-axis. I'm just reflecting it. That's all that really ends up meaning. And then last but not least, right here, you have a +2. So that would be a vertical shift up 2. So add 2 to the outputs. Once again, that's going to be a vertical shift. It's like a D value in your function transformation. Okay, so you're now just going to apply those step by step, one at a time, to each point. So check this out. Here's this first ordered pair. This ordered pair lives right there presently, but not for long because I'm going to move it. Where am I going to move it? Well, I'm going to move it to the right 1 unit. Okay, don't make a mark yet though. I also have to reflect it over the axis. So if right now it's 1, 2, 3, 4 units above the horizontal axis, I need to reflect it so that it's 1, 2, 3, 4 units below the x-axis. Don't make a mark yet, because then you also have to add 2 to the outputs. Vertically lift it up 2. So here's my current dot, but I'm going to vertically lift it up 2. That is the end of the transformation. So that is where that point lives. That's the new location of that ordered pair. Let's try the next one. I wonder, can I erase some of the marks I made? I can. Look at that. All right. So let's look at the next ordered pair, the vertical intercept one. So this dot right here on the vertical axis, that's where he lives right now, but not when we're done with it. So you're going to move it to the right 1 unit. Don't make a mark, just like mentally hold it in your head. Move it to the right, reflect it over the axis. So let's see, 1, 2, 3 units. So 1, 2, 3 units, but don't make a mark yet because you still have to lift it up 2. So right here is the new landing dot of that vertical intercept. Okay, what about this one? This dot lives right there for now, but we're going to move it. We're going to move it to the right 1 unit. Don't make a mark yet, but now you have to reflect it. Wait a second, aren't I already on the axis? How do you reflect it over the axis if you're on the axis? Well, you actually don't move it at all, because since you're on the axis, that means your output value is 0. And as you saw on the last example, anything times 0 is still just going to be 0. So that point, you move it to the right, you reflect it, but that kind of doesn't do much. But then, oh wait, you still have to add 2. So 1, 2 right here. And then last but not least, this ordered pair down here, that's where he lives for now, but you're going to shift it, translate it. So it's going to go to the right 1 unit. Then you have to reflect it. Ooh, okay. So this one, its original position is underneath the x-axis. So if you reflect that, you actually land up here. And think about it too. If you literally multiply it by -1, you've got a negative times a negative. So it makes perfect sense that we're landing in the positive axis space right now. So, okay, move it to the right one. That's there, reflected up here. So now I'm 1 unit above the axis. Oh, wait, still have to add 2. So 1, 2, right here. That is the new location of that dot. And so now here comes the point where you all get to laugh at me because this is just ridiculous. This one's going a little bit better. There we go. Okay, sort of. There we go. So that blue graph is the transformed version of the original. So again, main takeaway message, order of operations is a must. Okay. Every now and again, you get lucky. If you do stuff out of order, sometimes you get lucky. And then students are like, look, Bishop, it doesn't matter. And then I'm like, oh yeah, watch this. And I bust out with one that it does matter. So just don't chance it. All right. I'm telling you that order of operations needs to be followed the same way you would follow order of operations with anything else in order for your transformation to come out correct every time. All right. So once again, thank you for your time. I know that was kind of a long video, but it is what it is. Thank you for your time. Hopefully it made sense. And if you need me, you know where to find me. And I hope everything is going well and we will talk soon. Thank you.